Hello. In this video, we'll cover the following topics. We'll understand the link between conceptual design and database design. In previous tutorials, videos, you have watched how to create conceptual models with examples and the concepts. So this is a continuation of that video. Next, we're going to cover SQL Anywhere and an RDBMS tool, which we would use to create database tables. And using the same tool, we are going to create insert data in database tables and learn some basic SQL commands. So these are the objectives that we will be working in this particular video. So you have understood how to create an ER model such as this, where you have three concepts called professor, classes, and student. There are three entities. They are related as 1:m. That means professor can teach many classes. Class is enrolled by student. Student can take multiple classes. So classes and students are joined by m2n. So what we were going to do is we would convert this ER model, which is a conceptual model, to a database model in the tool. So which means that we are actually going to create database tables. And when we connect these database tables, it would look something like this, where you have a table called professor, you have the table called class, a table called student, and a new table called enrollment, which we will learn how or why do we need this table to create. Okay, so before we use the tool, let's cover some basic concepts on database design, and we will continue using the tool to show how do we create this. So if you remember, in the previous previous lecture, we talked about conceptual model, where entities are concepts which could be things or events. So in this example, on the left hand side, you see that entity called item and item number, description, cost, list price, quantity on hand. These are different attributes. So when we convert this into a database table, what we do is we see that item number is now considered as a primary key. There's a key that shows the sign of a key. And so on the right hand side is a database table, and the left hand side it's an entity. So once we create a database table, we have to do several things. For example, here you see that item number is primary key. It is an integer. It has certain number of values it can hold. Description has variable characters, up to 100 characters it can hold. It is not null. That means you must have some records, some values in the description. Similarly, cost, list price, quantity on hand. There are different kinds of data types. Numeric, that means it will allow decimal points, decimals. For example, 9,2 will allow hold up to $1 billion and 2 decimals for cents. On the other hand, quantity on hand is an integer, so it will hold value 1, 2, 3, something like that. There is a slight difference between varchar and char. We can use char, C-H-A-R, to assign a fixed size of the field. So if I say char 25, then the description will hold only 25 characters. But if I say varchar 100, then it is allowed to hold any size up to 100, and the size, suppose a particular record has only 10 characters, then the 90 characters will be freed up for other purpose. So we know that we have one-to-one relation, 1-to-n and m-to-n. So how do we link these tables if they are in this kind of relations? So we already know the concept of primary key, foreign key. So foreign key is nothing but a primary key which is placed in a different table. So which means that we need to create a primary key first and then refer it to another table to establish that link. So for one-to-one and one-to-n and n-to-n, we're going to see how do we connect these tables. What are the examples and how do we do that? So here is an let me cover this one. 1-to-n. In 1-to-n, what we do is we place the foreign key to any table. It doesn't matter which table. So we just pick up foreign primary key of one table and place it to another table. That is 1-to-1. 1-to-n is a little bit different. In 1-to-n, what we do is we place the primary key of the one-sided to the m-sided. So here you see that item number is a primary key on the item table. It is placed as a foreign key in item number in the quotation table. So how do we know this is 1 to m? This is because the symbol of ER is in crow's foot notation. So you can see that 1, the parallel lines, and that 3 intersection lines, those are 1 and m. So this is the relation, this is what we do in 1 to n. But for n to m, what we need to do is we need to come up with a third table, which is called intersection table. And the way we would establish the relationship is something like this. For example, we have student and class. You can see that student can take multiple classes and class can have multiple students. So we have m to n relationship. That means we need to have an intersection class. And here the intersection class is named as student underscore class. And the way we set up the relation is student and student class has 1 to m, and class and student class will have 1 to m. So because student and student class is 1 to m, we'll put this SID, the primary key, as foreign key in a student class. Similarly, the class number from class table will go to the class number at student class as a foreign key. In addition, student ID and class number, SID and class number together is considered as a primary key, and that's why you see 2 symbol of primary key under the student class. In addition, it might also happen that this intersection class might also have some attributes. A typical example would be a grade is an attribute of student class or the intersection class, because grade is an attribute that doesn't really belong to student class or class, student table or class table. Okay, so we now know how to combine multiple tables which are in different cardinalities. So let's go back to the ER model that we talked about, and we see that we know that if we want to create this kind of database design, then the ID that we have here, the professor, some kind of primary key or professor table, will be placed as a foreign key in the class table. And then we have to come up with a third or fourth table. We will call it as enrollment, because m and n are multiple, are in relation in multiple relations. So we will do that, and the output of that will look something like this. You can see here that the employee ID of professor is put as a foreign key here in class. Class ID is put as a foreign key here. Student ID is put as a foreign key here. Together, it is a class ID and student ID called primary key. So we'll create something like this, and that will be our database design. So let's start working on that. To do that, the first thing that we will do is we will click on the tool, which is our Sybase Central, and this is a server-based tool. So that means we are going to create a database server in the computer itself, and we were going to work on a client-server architecture. So once you open it, the tool is SQL Anywhere 12. The later version, you can also the same tool with a different version. So we're going to use only SQL Anywhere 12. There are other kind of tools which are available in Sybase Central, but we're going to focus only on this. There are tools which are like ultra light database or tools to create a mobile database, but we are not going to worry about that. So we double click SQL Anywhere, and what we're going to do is we will create a database. First we'll create a server, and then we'll create a database so that we can replicate the professor-student scenario that we talked about. So we will click on SQL Anywhere and then click on Create Database. So once we create database, there is a wizard that comes, and we are going to create the database on this computer. That means we're going to create a new server, database server in this computer, and within that server we'll create a database. So we click on Next, and we need to name the database. So let's place the database in the desktop, and let's name it as tutorial 1. So let's click on Save, and let's continue on, click on Next. We don't have to worry about these because these are basically related to how do we encrypt the database, what kind of log files are associated with, size, things like that. So we don't have to worry about that. Click on Next. Because it's a server-based connection, you will see that the database needs user ID and password. The username is DBA and password is SQL in small letters. So once you see that we created a server name and database name, click on next and let's finish it. So let it create a database space and let it create a database. So it's going to take a few seconds to create that, and I already know that the database server is created because I can see here that it says tutorial 1 right on the bottom part of the screen, tutorial 1 SQL Anywhere Personal Server. So in this database we can create a lot of tables and views and stuff like that. So what we will do is we will replicate something like this in this database, and let's create that. So the first thing that we do is we create tables. So let's double click tables and then click on create a table. So let's name the table as professor. Click on next, and we want a primary key on this table. So we'll say click on next and click on finish. So the first thing that it allows is to say that, okay, what's the primary key? So, and you see there is a check mark next to the primary key. That means whatever I write here, this field will be treated as a primary key. So let's write employee ID as a primary key, and data type, let's select integer. So I will just type int integer. And let's add a column. The column could be employee number or employee name, and we can create varchar. So varchar, and the size of it, let's say the employee name could be 25. So 25. Okay, so this is our table, employee table. Professor table, and we have only two columns, two attributes. One is a primary key, one is not. So let's go back and click on save. So now our table is saved. Let's go one step high and see that we have already a table called professor. Now let's create another table, and this time we are going to name this table as class, and we are going to follow the same system. We will have a primary key, and let's finish it and then name the primary key as class ID. It will be treated as an integer, so data type, let's write integer, and I think that's it for the primary key. Let's add a column, name of the column, let's say class name, class name, make it characters. It doesn't matter character or varchar for this exercise. So the character could be 25. Let's continue with that. Add another column. Let's call it as class size, and this time let's write it as integer, and let's add another column called employee ID. Now you will understand why I'm creating employee ID in a minute, and employee ID should be integer. Okay, the reason we created employee ID, because if you recall that our structure was professor and class were supposed to be in a 1 to m. That means primary key of professor should be placed as a foreign key here. So I anticipate that employee ID would be used as a foreign key. So I anticipate that and created employee ID in advance. Now, in order to set up primary key, foreign key, we need to understand one more thing, that is the data type of primary key, foreign key must be same. So if I can use any name, employee ID to make primary key, foreign key the same, but data type must be the same. Okay, so let's go and click on save. So we created two tables. Let's go back. You see that we have two tables. Let's create two more table, which is student and enrollment. So student table, we will create a table and name it as student. Here, let me click on finish, and we say student ID. This becomes the primary key. It would be integer. Next, we add a column, name it as student name. and we call this as a character maybe 35, and finally we add a column called GPA, and we use integer because GPA can hold only integers. Well, it can also hold decimal, but just assume it can hold we put GPA as an integer. Okay, so this table is created. Let's go and save this, and let's go up. We know 3 tables, and now we need to create the 4th table, which is the intersection table, and let's name this table as enrollment. And in this enrollment table we are going to do it in a certain way. It will have class ID as an integer, and it will also have student ID as an integer, but both class ID and student ID would be used as a primary key, so that's why I checked here. It might have another attribute called size, so I write size here, or class size, and it could be also integer. Okay, so we now have all the primary key set up. We have the 4 tables. If you go up, you see that these are 4 tables, and in fact you can examine the ER model of the 4 tables, which looks like this. So we have enrollment table, we have class and student, and we have professor. But you notice that though we have created these as primary keys and we had employee IDs set up for foreign key, but they are not connected because we haven't set up the connections. So now let's set up the connections and see how do we create primary key, foreign key. So we have these these 4 tables, and if you notice that employee will not have, or the professor will not have a foreign key, rather class will have a foreign key. So let's click on class, and we need to create a foreign key and such that employee ID becomes a foreign key. So how do we do that? We have constraints, so you see the primary key constraint, and foreign key is also a constraint, so we need to create a new foreign key. So you click on new, click on foreign key, and the question it asks is, where does the foreign key comes from? So we are creating a foreign key in class, so the foreign key should come from professor. So click on next, and automatically it identifies that the employee ID that we created in the class table is actually same as the employee ID in the professor table. So it understands that. Click on next, and then we can just finish it up, and automatically we are going to create a foreign key here. We can see that this is called a foreign key. So we also need to create one more foreign key, actually 2 more, that should be in the enrollment table. So in the enrollment table we have class, student both as primary key, but even class ID and student ID are independently foreign key. So we need to if you look at the constraint, there is it says class ID, student ID together as a primary key, but we need at least 2 foreign keys. So let's create the first foreign key. The foreign key, let's say that it comes from the class, and we already have class ID, which is a primary key, but this is also a foreign key in the enrollment table. So there is a match between class ID and class ID here, and this match, based on that we can finish. And so we see that we can created a class foreign key, class ID as a foreign key from the class table. Similarly, let's create another foreign key, and this time this foreign key should come from student. So click on next, and again there is already a match, so let's finish, and we see that there are 2 foreign keys. And so you need to understand this pretty clearly, that class ID and student ID together is a primary key in the enrollment table, but class and student are independently foreign key in this table. Class ID and student ID, class ID by itself cannot be a primary key in the enrollment table because it is already a primary key in the class table. So now let's look into the tables that we have, and let's see how we are going to see the ER model. And let's organize the ER model and see how does it fit. So now you can see this is the database design model. So we have a professor class. So it says clearly that employee ID comes from the professor table as a foreign key. It also says that the class ID, student ID together is a primary key, but class ID is a foreign key that comes from class. Student ID is a foreign key that comes from student. So this is our ER model, but remember that this is not just an ER model or conceptual model. It is actually a database model because it has the database structure defined into it. Now the next thing that we would do is, this is a structure. So we have the structure but in the tables, but we don't have any data here. So we need to connect the data, and to do that what we're going to do is we're going to write SQL codes. So let's go quickly on understanding what is SQL and how do we create SQL code, and then we'll come back here and develop the codes so that we can create some SQL, do some analysis based on this table. So SQL is actually a sub-programming language, and it's actually a standard. So basically it's not a programming language but a data sub-language which is often used integrated with other programming language. There are two parts of SQL. One is called data definition, another one is called data manipulation. Data definition is where you can write codes to create classes or views or other structures. In the previous example we didn't use SQL codes to write the structure, we directly use the tables. So the structure we can create, alter different kinds of database objects. So let's not worry about that. Let's focus on insert. Insert is when is a code that you use to write the data or insert the data in the tables. We're going to use in a little while to insert the data on the database that we already created. So the most popular SQL statement is called select statement. Basically it's a manipulation statement. So it uses certain keywords such as select, from, and where, and in this format to retrieve data. So it says that select employee name from employee table where the condition is employee ID equal to this, and then you put a semicolon. In this particular tool we don't need to use semicolon. It's still going to work. So when we execute this query, it's going to pull up the employee name whose employee ID is this. If we use a text-based field, we need to also put a quote, single quote around this. So the query pulls information from one or more tables. That means here we have used only one table, but you can potentially use more than one table in this particular case. So if you don't want to specify which particular column we want to retrieve, you can just place star and then it will retrieve all the tables. So if certain columns are duplicated, the rows are duplicated, you can use the word distinct so that only the duplication will be removed, and you can get the output. So we already talked about the where clause. Where is a condition that you add to restrict. It restricts the data in terms of the criteria that you get and the output. Where is used in parallel with a lot of operators. So you can use equal to sign, not equal to sign, greater than, less than. These are inbuilt operators in the SQL. We can also use where with match operators like and or. So if you look at this example, employee name, employee, department ID less than 7 or department ID greater than 7. That means pull out all employee names which have department ID less than 7 and include that with whatever you have department ID greater than 12. So or actually increases the size of the output because it pulls this or this. Whereas and is a little bit different because what it does is it's much more restrictive. It says that okay, not only pull data where employee name is from the department ID 7, but also pull out the same employees where the salary code is less than or equal to 23. So if I don't use the last line, you can see that the output will be much more than when we use the last line. There are a lot of different kinds of SQL queries. We're not going to go through that in details. Here is an example where you see that select employee name from department ID in. So when you say in, then what it does, it only pulls out records from department ID which is 4, 8 and 9 and ignores the rest. You can also do the same thing, not in, that means pull out everything except 4, 8 and 9. Between and are also used in conjunction, that means select everything between 10 and 9, 10 and 45. Instead of using equal to, often we have a more powerful search which is called like operator. So if you want to find out an exact number of characters, then we use this single characters. But if you want to use, we don't know exactly how many characters we need, then we use a wildcard called percentage. So here's an example. So if you say select employee ID from employee name, where employee name like KR percentage, so there is a quote here, that means this is text, employee name is text. Employee name like KR means pull out all the employee name that starts with the letters KR. So KR followed by any number of characters as long as they are in the database. But if we know in advance that KR can be followed by only 3 digits or 4 digits, just like an employee, like a phone number, because we know that phone number will have only 10 digits, here 3 digits and here 4 digits, then we are going to use where phone like, and then we leave this as blank. So wildcards are very useful in SQL. Another important thing that we often do is called order by. Order is basically sorting the data. So if we say select star from employee order by employee name, that means the database will be sorted out by employee name. By default, the sorting will be ascending. If you want to make sure that it is descending, then we have to use DESC along with this query. SQL comes with quite a few inbuilt queries: count, min, max, sum, and average. So here what you see here is select count department ID. Department ID is unique, so you can find out what are the total number of how many department ID is there, and then so this itself is a code that will result in one row. Similarly, you can use hours and create these functions: min hours, max hours, average hours from a table called project, where project ID is greater than 7. Here, along with this, we also use alias. What we do is here we write as and then write minimum hours. So in the output, you will have only one row, and the headers of these will be there will be 3 headers called minimum hours, maximum hours, and average hours. Often, if we use group by, if we want to group the data, when we use specifically the count or this kind of functions, when we use group by, then we need to specify that a clause called having clause. So group by and having go together. Often we use multiple tables. For example, here you see that employee table and department table are joined together. So here it says employee as E, department as D. So these are alias. So E means employee. So you don't need to write the full employee name here or full department here. So to do the join between those two tables, you need to pull out primary key for foreign key. So it says employee.department ID equal to D.department ID, and pull out department name like account. So anything which starts with account, pull out those records. So if we want to join tables, this is a very key sentence or a clause that we need to use to set up the primary key, foreign key. We can use many tables, not just 2, 3, 4, 5. More tables we use, more kind of where statements we will use. SQL is also used to insert, update, delete, and we're not going to worry about that now. So with this knowledge of SQL, specifically the select statement and insert statement, let's insert some records in our in our database, which is the class, student, enrollment, and professor. Insert some records using the tool, and then we are going to use some queries use some select queries to extract some data from these tables. To use the insert statement, what we are going to do is we are going to use SQL statements. We are going to use SQL statements. So therefore, we need another tool, and for that, let's the way to do that is we'll first disconnect this particular tool here. Click on disconnect, and we go to SQL Anywhere. Go all the way to something called Open Interactive SQL. In this Open Interactive SQL, we are going to set up the connection so that we can access the server, the database for the database server, and this is the way it is set up. So first is user ID. User ID is DBA. Password is SQL. And if you remember, I saved the database in my desktop, so I'll go there and click on the tutorial 1 database and open it. So we need to find out where I saved the database, username and password, and set a connection. So when I do that, my interface, I get connected with SQL Interactive, and this is how it looks like. As you can see here, at the top you can see it says DBA tutorial 1. That means it is connected. The interactive SQL is connected to this database. So I'm going to write the SQL statements here and then execute here to see the output. Now if you remember, we created several tables, and these tables have no data. So if we type a code which would be something like this, such as select star from student, double click student, okay, and then click on the play, and you see that it just displays 3 fields, but there is no data because we haven't inserted data. And if you do this with other tables, the result will be similar. Professor, you run it, and you will see only 2 columns and no names. Okay, so how do we insert data? So we can insert data by writing statements such as this, and we can do all of them in one shot. So all of the lines will be inserted one at a time, and the data will be inserted. So let's start with this. Insert into student values 1, John, 3. That means in the table student, insert in this sequence 1 will be the employee. So let's this is student. Okay, so in 1, let's look at the student table. So in 1 means a student ID, John is student name, and 3 is the GPA. So GPA is 3, 4, 3. So this is done in certain order, and notice there is no quote in 1 and 3 because these are numbers. So if I write these statements, let's say copy them and paste it here, you will see that insert into student values this, and they will be inserted. So if I click on select, if I click on run, they will be inserted in the database. I can check that by writing again select star from student and run it, and now see that student ID, student name, GPA, now these are the values. Now just be careful that once you insert the data, you cannot insert the same data again. For example, if I now type these and put it here, I will get an error because I have already inserted 1, 2, 3, 4, 5 as primary key. 1, 2, 3, 4, 5 as primary key. So I cannot repeat the same primary key because primary key for this particular table will be unique. So keep that in mind. So also make sure that you need to insert the primary key first, then the foreign key. So if you remember, professor table, the professor table has this is student, so this is fine. But if we have let's understand this clearly. So suppose we are entering data from professor and class. I need to enter data first in the professor table followed by the class table, because employee ID needs to be here first, then it should be referred by in the class table. So I cannot create this table first, data first. I cannot create or insert data in this table first because it will refer to the professor table. So let's add data to the professor table. So therefore it is important that the order of the data which is inserted is important. So let's click on insert the data here, called insert into professor values, and then you see once we do that, we can check again that whether there is a data in professor. Select star from professor, and we see that the professor has data. Now let's add data to the class table. So, and you can see the class table is done in such a way that we have, this is the class ID, this is the class name, this is the class size, and this is the foreign key. And as I told you, employee ID. So employee ID must be inserted here first, so that will check the employee ID here and employee ID here in order to insert this record. So let's copy this, paste it here, click on, and you can now see that if we write select star from class, if we run this, we will see that we have data as we expected. Finally, let's add the data from the last table called enrollment in this table, which is the last set of value, and then click on this, add the data and paste it here, click on run, and again let's replace this and say select star from enrollment. We see that we have the enrollment data. Now once we insert the data, we don't need to save it again, it's already saved, so we don't have to worry about it. So these commands, when it is executed, then the data is inserted row by row and we have all the data. So we use insert statements to add data, but the most important function of SQL is not just insertion data, but actually to use different kinds of codes to understand or analyze the data that we have. So now we are going to write some SQL select statement codes to pull up records from these tables, maybe one table or more table, and get some output. So that's what we are. Okay, so what we do now is to answer these questions using the queries. So you can see there are 5 questions, and we'll write select statements to answer these questions. So let's take one question at a time and then analyze how to write the select statement and how we extract the data from the database. So to recap, we started with an ER model of the professor-student situation, and then we converted it into a database, tables, then we inserted the data, we connected them in primary foreign key, inserted data, and now we have enough data to do some kind of analysis as we see here. So the first question, what are the names of the students who have GPA more than 2.0? So we are looking at this, and we know that to answer this question, we have to look at carefully only at the student table, because student table has GPA and I need only this table to answer it. So let's write the query first for what are the names of the students who have GPA more than 2.0. So we are going to write the query right here, and we are going to write select. We're going to write select, and so we have to first is the select statement. So we are going to display on the student name. So we write student name, select student name. So I see student name from student table. So select student name, and the next keyword is from. So write from. Select student name from, table name is student, and then we have the where condition, where GPA greater than 2.0. We don't need a quote here because it's a number. We have select statement, select DBA student name from GPA from student where GPA greater than 2.0. Let me copy this and paste it in our notepad so that you can see that in a better way. So let's magnify it, and okay, here it is. So here you can see this is the code that I wrote. Select student name from student where GPA is greater than 2.0. Okay, so if we execute this code, we see that 2 students have GPA more than 2, to John, Sean and Mary. As I told you that the last statement is always a restriction, is a class. So if you remove the where, you will see the number of data records will increase. So from 3 it became 5. So because it includes every record, everybody from student just with the student name. Now let's look into the next query where we are interested in finding out the second one, which professor teach which classes. Now to write SQL statements in advance, you need to find out what are the tables that you would use to say that which professor teaches which class. So we have professor, we have class, so I need the primary key foreign key connection between professor and class, and then I would be able to execute this query by connecting these 2 tables. Okay, so professor and class, if you remember how these 2 tables are connected, they are connected by employee ID. Employee ID is the primary key here and employee ID is the foreign key here. Okay, so let's run this query by typing the select statement. So we will say select employee name. So the employee name employee name is in the professor table, so select employee name, comma, class name. Class name is the class in class table. Now notice here, when I double click those right now, what it did is it pulled out professor employee name from the professor table, class name from the class table. Now this is important when we use more than one table. And then we write from professor, comma, class, and now the where condition. Here we need to have the primary key foreign keys connection, so we write employee ID from professor table must match employee ID from class table. So this is the way we do the match between primary key and foreign key. Professor.employee ID equal to class.employee ID. So this is the connection between these two tables, professor and class. So when we execute this, we see that these are the employee name and the corresponding class names. This is what we wanted. Okay, now let's look at the third query. In the third query, we say that which professor teaches classes that have more than 25 class size. So what you see is this query is nothing but the modification of the existing query, only with an additional class called AND. Okay, so how do we handle that? To do that, what we will do is we write exactly what we have, only we add AND class size, let's double click, class size greater than 25. Okay, so let's execute that, and now we see that Bill teaches in the class name called business analytics, which has class size more than 25. Okay, so we have two more queries. The next query is in which classes have students enrolled in. So in other words, we are asking this question, in which class. So let's okay, by the way, I need to show you the exact code for this query. So let's copy it and put it in a bigger size here, so you know that the answer to query number 4 is this, the answer to query number 3 is this, except this last line. Okay, now let's move to the fourth query. So the query that I want to write now is in which classes have students enrolled in. So that means we need to see how classes and students records can be pulled together. But when you look at the ER model or data model, you see that there is no direct connection between class and student. That means I cannot say that primary key of class is in the student and primary foreign key of start is student. No, that's not the case. Rather, class and student is connected through enrollment table. That means if I want the data from this and these two tables, I have to go through this table. That means I need three tables: class, enrollment, and student. So first I have to do the primary key foreign key from class enrollment, and then primary key foreign key from enrollment and student. Only when I do this, I'll be able to link class and student. So this is important to understand, because not all the times the tables are directly connected. Sometimes the tables are connected through one table or two tables or more tables. So we need to follow the connections and set up the primary key foreign key accordingly. So let's write the query here for the fourth question, in which classes have students enrolled in. So what we do here is first we write in which class. So we write student name and class name. So select student name. So student name is in the student table, comma, class name from the class table. As I told you, student and class are directly not related, so we need to go through three tables. So we say from student, comma, enrollment, comma, class. So we have three tables now, and then we have the where condition, and here what we were going to have is two where condition, where the first where condition is the primary key foreign key between student and enrollment table. So we write student ID from the enrollment table must match student ID from the student table. So this is one where, and then we have another condition. So we write another and say class ID from class table must match equal to class ID from the enrollment table. So let's look at carefully. Let me copy and paste it so that you can see the code carefully. So here is the code. It says select student name from the student table, select class name from the class table, but notice that class and student are not directly connected, so we need three tables: student, enrollment, and class. The enrollment, the first statement, student ID, this one sets up the connection between student and enrollment table. The last statement, class ID and enrollment class ID, is established by doing the primary key foreign key between these two tables. So because we do this, write two sets of join, therefore we are able to collect or connect these three classes. So if you run it, we see that John, class name is, student John is taking two classes, database design and business analytics. Mary takes business analytics, finance, and Max takes marketing analytics. So this is how we set up connections between multiple tables. And if you want to be a little bit more specific, that the last query, which is the same query but a little bit more precise, which is says as I don't need student name for all student name, I just need to know in which class John has enrolled. Okay, so to do that, we are going to modify the code that you already wrote here, and what you're going to do is just write another AND statement. Say AND student name equal to, in single quote, John. So let me put this together so that you can see this better. You can see that AND is always restrictive, so that means, okay, I don't need answer. So if I run this, I'll get this, but I need to know student name only for John, so it is much more restrictive, only for John. So when I write this and click on select, I see that John is enrolled in two courses called database design and business analytics. Okay, so this is how we create a select statement, and this is just an intro, and you can imagine that there is a huge possibility of joining different kinds of tables, different kind of operators in different combinations to create a lot of complex SQL statements. So that's the end of the tutorial on SQL. So we covered the concepts of different, we did cover starting with the linking between conceptual design and database design, and then we used the tool to create the 4 database tables, and we used insert into commands through our SQL tutorial. This is the interactive SQL to connect to the tables and insert the data, and then we are using it to go to write the different kind of select statements. Now once you are done, the next thing what you do is, because you are working with a different interface which is interactive, so you need to go and disconnect it. So once you disconnect it, then you can go back to the main tool and set up the connection again. So you can go back here, connection, then you say connect with SQL. Again you need to do DBA and password is SQL, and then you can connect to the database. So in other words, what you see here, this tool, so you can see the database is this is the different this is the database, and we have all the tables and everything here. So that means you need to go back and forth between database and from this tool to the SQL Interactive. In other words, you cannot connect both SQL Interactive and the Sybase together into the database. So that's how we do. So we have this SQL, we have these tables here. I'm able to connect and see this table because I already got disconnected from the interactive tool. I can add more tables, I can add more, link those tables in different ways, and continue from there. Once you are done, don't forget to disconnect the server. If you see here, this is the server. It's called personal service activated. You need to right click and shut down, otherwise it's going to say shut down, yes, and then you would be database, you don't need to save anything from the SQL. so you're going to shut down and the database is disconnected. Otherwise the database is going to keep on running on your computer without even you're aware of.